2022 Life Sciences Section S Microbiology question number 84. What will be the value of numerical aperture NA if the half aperture angle is 58 degree and oil dimmer's objective is used for the process of light microscopy? Okay, so they have already given that sin 58 is 0.85 and the refractive index of oil immersion used is 1.5. Okay, so we'll first understand the concept of numerical aperture. So what is numerical aperture? Numerical aperture is nothing but is nothing but the amount of light. Okay, it is amount of light collected. Okay, so this amount of light collected will tell us how much the object will get resolved. Okay, so it is the amount of light collected from the lens. Okay, so this is the light. Okay, so here we have source. Here we have source, right? Here we have source in the microscopy system, and the light reflects on the specimen here. Okay, and this specimen light is again collected. Okay, this specimen light is reflected back and it is collected by the condenser, and this collected light, the amount of light which is collected will determine the numerical aperture. Okay, so this numerical aperture mainly measures the amount of light. Okay, this is very important. It measures the amount of light. So if there is maximum amount of light collected by the lens, we'll have more resolution. Okay, so there is resolution and there is magnification too. So magnification is nothing but we can magnify. So we have a 2 micron E. coli cell. This 2 micron E. coli cell we can magnify it to by 100x. Okay, 100x magnification by using oil emulsion. So this 2 will become 200 micron. Okay, and 200 micron is visible to our naked eye. Okay, that's why we are able to see E. coli under microscope but not with our naked eye. And resolution is nothing but if we have two objects, resolution is how these two objects are resolved from each other. Okay, how much clarity is between these two objects. So if these objects are close by, so they are not much resolved. So if we are using a particular high resolution microscope, then we could get two resolved objects. Okay, so resolution is nothing but ability of a microscope or any instrument to resolve two nearby object. Okay, that is resolution. So we have this formula. Numerical aperture is n sin theta. Okay, n numerical aperture is given by general formula n sin theta, where n is equal to the refractive index. Okay, n is refractive index and theta is the angle. So what is theta? So this is the light. Okay, so here the light is traveling in this direction. Okay, it reaches to the specimen here. Here is the specimen, it reaches and it reflects back. So this angle is theta. Okay, this and this angle is theta. This is the theta angle which we are measuring here. Okay, and the light is getting reflected back. So here, so so this is the theta. Okay, and this is the distance. This is the distance of numerical aperture. Okay, if this is a distance, so how can we write it? Okay, so this is the mu right here. This is the mu theta angle or theta, and n is the refractive index. So as I mentioned, we need, in order to resolve especially a object, we need a higher numerical aperture. Okay, if the numerical aperture is higher, because if the numerical aperture is higher, it will measure it will measure that is it will capture, the lens will capture more amount of light. Okay, capture more amount of light, yeah, right, because numerical aperture is defined by the amount of light collected. So if there is high numerical aperture, it will capture more amount of light and we'll get higher resolution. Okay, so how can we increase numerical aperture? So numerical aperture, as you can see, is directly proportional to the refractive index n, and it is directly proportional to the sine theta, right? So we need to have, so as you can see here, the theta is increasing, so numerical aperture is also increasing. Okay, so as the theta increases, the numerical aperture also increases. So basically, as you can see here, the theta is less, here theta is highest. Okay, here theta is 20, here is 7 degree, because this angle is very narrow as compared to this. Here the theta is 7 degree, here it is 20 degree, and in third case we have 60 degree. Okay, this is more wide, this is more wide angle as compared to this. Okay, yeah, so generally if you observed that when we use a 10x magnification, we have to adjust the lens, objective lens, at a very high length, whereas if we use a 100x magnification, we have to submerge this, right? We have to submerge this, and then we put a drop of oil, right? We put a drop of oil here, so that the lens, so this area is completely submerged in the oil. Okay, and there is very narrow space in between them. So here we have the here the refractive index will be accounted for the air, because here there is a space. So here n will be equal to 1, but the refractive index of oil is how much? Around 1.3, right? The refractive index is higher, so that's why we get higher magnification. So this in 100x, with oil we get more magnification and resolution. Okay, because oil has a higher refractive index, and numerical aperture is directly proportional to the refractive index. So we have a slide with staining of microorganism. We put a drop of oil, and then we stick, and then we put the this, here is the objective lens of microscope. We stick the objective lens completely, so that there is a thin film of oil around the objective and the specimen. So this whole area is covered with oil, which has a higher refractive index, and hence we get a higher resolution. And more denser the oil, so oil also we have very dense oil and very thin oil. Okay, the density of oil also matters. If it is a high dense oil, then there will be more refractive index. Okay, so coming back to the question, yeah, so the immersion oil is used, so the refractive index now we have is 1.5. so air has refractive index of 1, yes, 1.33, and oil has refractive index of 1.50. Okay, so so oil immersion lens can be only used with 100x. Okay, why? Because that 100x objective nearly sticks to the specimen, and this space is completely filled. This space will be filled by oil. Okay, to get more resolution. Okay, so here the question is now pretty straightforward. Numerical aperture is nothing but n sine theta. We have n 1.5 and sine 58, 1.5 into 0.85, which is how much? 1.28. Okay, so they have said up to 1 decimal, so we can write 1.3. Okay, so the answer is 1.3.